Hi to everyone, welcome to my channel. This is Rakesh. Today we are going to discuss about multi-gate synthesis. As we know that threshold gate or T-gate is only applicable for unit functions, but for non-unit functions a T-gate is designed using multi-gate synthesis. Multi-gate synthesis. In this, the cascading of two T-gates gives us the required output of the non-unit functions. Now, let us discuss about an example of XNOR gate. So, as we know, the Boolean expression for XNOR gate is F is equal to A bar B bar plus AB, and the required K map is A B 0 1 0 1 and the decimal equivalent 0 1 2 3. Now A bar B bar here 1 and AB here is 1. Now as it is a non-unit function, we must split this function into two functions. That is, let first function be FA. Let FA be A bar B bar, and let our second function be FB. Let FB be A and B. Now this function is a negative unit function, so it is a unit function. This function is a unit function. Now as it is a negative unit function, now first convert this into a positive unit function. That is, FA is equal to AB, and now FB is always, and it is a positive function. Let FB is equal to AB, and now finding for false prime implicants on both sides. Now find false prime implicants for both the equations. That is A bar B bar, means we get only one here, so replace the empty boxes with zeros, so we can find the false prime implicants. Now A B 0 1 0 1 0 0 0. Now the equivalent Boolean function is F A P, that is F is false prime implicants, that is AF, F A F. Now the required Boolean expression is A bar into B bar. Now for here also find the false prime implicants in the same way as we calculated for FA, that is 0 1 0 1 0 0 0 in these three places. Now by performing the K map, we get false prime implicants of FB is equal to A into B. Now as the false prime implicants also contains the negative terms, so we must convert it into the position. That is, FAP is equal to AB and FBF is equal to AB. Now as we got into the false prime implicants, that is FAF is equal to AB and FBF is equal to AB. Now we must calculate the expression. That is, we must know that the minimum value of true prime implicants must be greater than maximum value of false prime implicant, and the same applies to this in here also. That is, minimum value of true prime implicants must be greater than maximum value of false prime implicants. Now for generating the algebraic expression, we know that FA contains A and B, so we must write here A plus B, that is true prime implicants must be greater than the false prime implicants, means A into B. Here also A into B. Here For the terms on A and B, only A is present, so B is absent. So we must write B. For the second term, A is absent, so here A. In the same case, A plus B must be greater than B plus A. Now we must assign the values of A and B such that the minimum value of this expression must be greater than the value of this expression. Now let us consider A equal to B equal to 1. In the same case here also, A is equal to B is equal to 1. Now let us see that A B is equal to 1. That means 1 plus 1, 2 is greater than 1. Here the 2 greater than 1. So these values satisfies the condition. So now A is equal to B is equal to 1. Now from the original function, in original function we have A as A bar and B as B bar. Then value changes as A is equal to -1 and B is equal to -1. In here, in the original function, we have A as A and B as B. Therefore no change occurs. So A is equal to 1 and B is equal to 1. Now we must calculate the threshold gate value, that is T value. For calculating the T value, we must have the maximum value of true prime implicants is 2 and the minimum value of false prime implicants is 1. So the threshold value TAF is equal to 2 plus 1 by 2. That is the mean of maximum value of T.P.I and minimum value of F.P.I. That is equal to 3 by 2. Now as A value is negative and B value is also changed from 1 to -1 and A value is also changed from 1 to -1. Now the original threshold gate value TA is equal to TAF minus A minus B, that is 3 by 2 minus 1 minus 1, which will be equal to 3 by 2 minus 2. The final answer is minus 1 by 2. That is the value of threshold gate T value of for FA is minus 1 by 2. And in the second case for FBF, here the maximum value of TPI is 2 and the minimum value of FPI is equal to 1 by 2, which will be equal to 3 by 2. Here TB is equal to TBF because here the values of A and B are unchanged. So then TB is equal to 3 by 2. So these are the respective T values, that is threshold values of the first. Now draw the T gate for FA and for FB. The T gate is as follows. The weighted sums are -1, -2 and the T value is -1 by 2. Let it be x1, let it be x2. And for FB, the weighted values are 1, 1 and the T value is 3 by 2. That this is F. Let this be x1 and let this be x4 and let this be x3, and this is the value FB. Now for the value of, now we must cascade these two T gates in order to give the output. Now for cascading these two gates, we must obtain the value of Wx. Now to calculate the value of Wx, the value of Wx must be greater than the value of TB, because the value of Wx is only affected when there are two cases: if FA is equal to 0 and if FA is equal to 1. If FA is equal to 0, the total output doesn't depend on the first one. So it only depends on the second one. So in that case, the value of Wx is not necessary. So when the output of Fa is equal to 1, then the value of Wx becomes crucial in order to obtain the input. So now if Fa is equal to 1 and to obtain the output F, we must calculate the value Wx, and so the value of Wx must be greater than the second T-gate threshold value, that is Tb. Now as Tb is 3 by 2, that is Wx must be greater than 3 by 2, that is 3 by 2 means 1.5. So here we can take the value as Wx as 2. Now the cascading the two stages, we get as -1 as weighted gates x2, this is 1 by 2, and this gate is connected to the second T gate as the weighted sum as 2, that is Wx is equal to 2, and the weighted codes x3 is 1 and x4 1, and here 3 by 2, that is we get the value F, and here Fa. So this is the final expression, that is final T gate of the XNOR gate using multi-gate synthesis. Thank you.